What's up, everybody? Good afternoon to all you folks in the U.S., all you folks abroad, good evening. And I know it's late in some other countries and cities in Europe, Asia, the Middle East, etc. So, whoops. All right, cool. So, we are live and we are going to continue to plow through these SAT problems and in particular math SAT problems. So today we are going into the October 2018 official SAT given in the US. And in just a quick caveat, now normally I like to take these tests completely blind so you can see me problem solve in real time. So the caveat is that I actually took this test, I believe. This is the one, I think I took the October one, I'm pretty sure. So I haven't gone through it yet, but I think it's the one that I took officially. So I have seen it before, but it's been a while. It's been a long time. It's been like 6 months since I've looked at it. So hopefully it'll still feel fresh and feel authentic as I'm taking, and you'll still get the same value. I recently got some feedback today from one of you guys that's watching that it's a little bit hard to read the questions. So what I've done now is I've zoomed in super far into so you can see it very clearly. The only thing is it's going to slow me down a little bit as I'm maneuvering, but I think it should be okay because usually I'm able to finish these tests with some spare time. So again, I'm still trying to take it in an authentic timed setting, and hopefully I'll still be able to do that. And please give me your comments and feedback as well. Let me know if this is a better format with a bigger view of the question types and more zoomed in. So I really want this to be the best and most powerful experience for all you guys preparing. Just one more quick announcement. I have a paid session if anybody is interested and wants to come in and ask me and send me specific questions outside of this SAT. If you want to say, hey, I went across this question or that question in my practice materials and I have no idea how to solve it, makes no sense, you can come on. It's $10 to join, and you can then submit the problem and I'll solve it live. That session should last about 45 minutes. I don't know how many people are going to join, but it's sort of a group thing, so you guys can come in and we'll have a queue and you can ask questions and also watch the questions that other people are asking so you can learn from that as well. All right, so without further ado, hey guys, what's up everybody? Omar, what's up? Bra, Khaled, Iman, Mohammed. All right, welcome to the stream. Without further ado, here we go. I got the timer set up. So just FYI, if you guys are new to my streams, I won't be able to answer questions while I'm streaming because I'm engrossed in the test. But as soon as it's over and I check my work, then I'm going to answer all your questions. So keep them on the chat, and I'll go in order from first to last, top down. Okay, here we go. Ready? This is the No Calculator section, October 2018. And push this back. All right, and begin. What value of z satisfies the equation above? So we just isolate. So I'm going to subtract z from both sides. Boom, boom. That's 2z minus z is z plus 1 equals 0. Subtract 1, subtract 1. Z equals -1. Okay. Next, a television with a price of $300 is to be purchased with an initial payment of $60 and weekly payments of $30. Which of the following equations can be used to find the number of weekly payments required to complete the purchase? So we're paying $30 per week plus this $60 that we already paid, and we want to know when this is going to equal 300, and that's our equation. 30W plus 60, this is the weekly payments, and this is the initial payment, and we want to know when it all adds up to 300. So the subtraction, this makes no sense. This makes no sense because there's no 60 in there. This almost makes sense, except they're subtracting 60. You wouldn't do that. You'd be adding it. So C. Okay. Next is shipping charges. The table above shows the shipping charges for an online store that sells sporting goods. There's a linear relationship between shipping charge and, okay, which function can be used? Okay, so we want to find a linear function. So look, if it's linear, okay, that means, and it's shipping charge, this is my y, this is my x. First thing we need is calculate the slope. So we take the difference of this guy over the difference of this guy, right? So 1694, okay, this is a little messy. So I'm going to subtract up, actually, in this case, bigger to smaller, so both will be positive. 2189, 1694, subtract 5, 0, 9, 110 is 4. So it's 495 per, and then on the bottom, 10 minus 5 is 5. So the slope is the difference of the y's, 495, over the difference of the x's, which is 5. Okay? Then this looks like if I do 495 divided by 5, I'm pretty sure it's 99 cents. It can't be 339. So that's my slope is 99 cents, and I'm just going to go ahead and assume it's one of these two. And then the question is, do we start at 0 or do we start at 11.99? I know we start at 11.99 because if I reverse back by 495, I'm not going to 0, right? The next one up would be 0 pounds, and going up in the same linear progression would be subtract again 495, so it would be 1294, 1199. Yeah, it's 1199 exactly. So that's my y-intercept, and boom, done. Okay, next. The line in the xy plane above represents the relationship between the height hx in feet and the base diameter in cylindrical Doric columns in ancient Greek architecture. How much greater is the height of a Doric column that has a base of 5 feet? So hold on. Base is x, so here's 5, so here's that point. Then the height of a Doric column that has a base diameter of 2 feet, boom, so there's that point. So it's these 2 points we're comparing. Let's make sure I understood everything correctly. And the height of base diameter x in feet for cylindrical. Here's the height of a Doric column that's a base diameter of, okay, so here it is. This one has a height of 35, this one has a height of 14. How much greater? We just subtract, and it's 21. Next, if x is greater than 0, which of the following is equivalent to the given expression? We take the square root of each part. Square root of 9 is 3. Square root of x squared is x. Done. What are all the values of x that satisfy the equation above? Okay, remember I told you my instant tip is just to factor if we don't know nothing else. So I'm going to factor the top. It's a difference of squares, so it's x plus 1 times x minus 1. That's how we do a difference of squares over x minus 1, right? Because these are the square roots of that, and these are the square roots of that, and then we always have plus minus when we factor. Now let's cross cancel x minus 1, and we get x plus 1 equals negative 2. Subtract 1, subtract 1. X equals negative 3. So that's, I think, our only solution. Now the only thing to question is we've also got a solution of negative 1. And so these are out because we know negative 3 has to be a solution. So is negative 1 also a solution? Well, that would give me, no, it wouldn't, because negative 1 squared is 1, minus 1 is 0 over negative 2. So that'd be 0 over negative 2 does not equal negative 2. So that double solution is out. Next, 7. The graph of y equals f of x is shown in the xy plane. Was the value of f of 0? So again, f of 0 means where x, see how they're replacing x with 0? So what is the value of the function, meaning the y value at when x equals 0? It's right here. F of x equals 4. Okay, in the figure above, point B lies on AD. What is the value of 3x? B lies, okay, cool. So check this out. This set is a right angle, so we're going to assume that that's a right angle too, which means that these 3 angles all comprise that right angle, and they all add up to 90. So there's my first equation. All these add up to 5x equals 90. Divide by 5. A nice trick when dividing by 5 is divide by 10. 90 divided by 10 is 9, and then double that answer is 18. So we know that x equals 18. So now they said, what is the value of 3x? Very tricky, right? Because you could go for the 18 when you solve for x. 3 times 18 is 54. They do this a lot now on the SAT, so watch those tricks. Which of the following is an equation of line L in the xy plane above? Okay, first of all, line L, it has a slope, y-intercept of negative 4. That's where it crosses the y-axis. It's got a slope of down 1 over 1, down 1 over 1. So it's basically negative 1 over 1, or negative 1, x minus 4. Now, the question is, wait a minute, all of these have this guy isolated, so it's not just this. And let's simplify this. It's y equals negative x minus 4. We want this value isolated to look like these guys, so I'm going to add x to both sides because it's a negative x. Boom. And I'll put the x in front like they have for all these. X plus y equals negative 4. Boom. Okay. Numero 10. The graph of 2x squared plus 10x plus 12 is shown. If the graph crosses the y-axis at point 0, okay, sure. What is the value of k? Oh, just it's 12. Because you just basically plug in 0 for x, right? That's the point, 0k. And these guys cancel out and you get 12. So k must be 12. Boom, done. 10, 11. A circle in the xy plane is a center of 5, 7. So that means the circle equation is x minus h, which is the x value of the center, which is 5, squared, plus y minus k, which is the center y value, which is 7 in this case, squared equals radius squared, which is 2 squared. And there's our equation of the circle. And it is this guy. X minus 5 squared plus y minus 7 squared equals 2 squared is 4. So that's it. Next. In the figure above, triangle ABC is similar to triangle DEF. So these guys are similar. And the order matters. So AB is similar to DE because it's in the same order. BC is similar to EF, but it looks like that. So we can tell that's true. What is the value of cosine of E? Now, here's the beautiful thing, okay? When we say something like this and we know they're similar, cosine of E, we don't have to find these values. Cosine of E is the same as cosine of B because similar triangles have the same trigonometric ratios. As long as we find the angle that corresponds with E, it's B because B is in the center and E is in the center. So what's cosine of B? It's adjacent over hypotenuse. Adjacent side is next to it, which is 12 over hypotenuse. The longest side is 13. Okay. So far, so good. We are more than halfway through, and we got a solid 16 minutes left. So that is excellent. Okay, this has 2 x-intercepts. What is the distance between the x-intercepts? Let's find the x-intercepts. That means where y equals 0, and I'm going to go straight to factoring to find those zeros. It's x plus 4 times x plus 1. Why? Because what multiplies to 4? 4 and 1, and adds to 5, 4 and 1. So then my x-intercepts, so the distance between the x-intercepts, it's where these equal 0 are where x equals -4, because -4 plus 4 equals 0, or x equals -1. Boom. So those are my 2 values, and we can just plot the x-axis here. One is going to be at -1, one's going to be at -4. What's the distance between these two? It's 3. Next. What are all the values of x that satisfy this equation? Solve for x. So first of all, I don't like this square root, so I'm going to square both sides, but don't forget to FOIL. So 4x, square root of 4x squared just becomes 4x. And this becomes, really it's x minus 3 times x minus 3, which is x squared minus 3x plus 9. Combined like terms, 4x equals x squared minus 6x plus 9. Now let's subtract 4x. We want to set everything equal to 0. Remember, with quadratics, we're just thinking about factoring, and this is a common process. So then -6, -4 is -10x plus 9. Now let's factor this guy. What multiplies to -9 and positive 9 and adds to -10? That's going to be -1 and -9, right? Gives us a -9, adds to -10. My 2 values for x are, x equals 1, x equals 9. Now, I don't know yet if both of these work. We have to plug them in and check. You got to be really careful with these radicals. So first I'm going to plug in 9. So 9 times 4 is 36 equals 9 minus 3 is, right? 9 minus 3 is 6. Square root of 36 is 6. Okay, boom. So 9 definitely works. So anything that doesn't include 2 is out. Then let's plug in 1 and make sure that works. So it'd be the square root of 4 times 1, which is 4. Equals 1 minus 3, square root of 4. We're going with the positive root. That gives us a negative. No good. So 1 is out. So it's only 2, and we're rolling with B. Okay. Last of the multiple choice. So this should be one of the hardest problems. In the system of equations above, A is a constant. For which of the following values of A does the system have no solution? All right. Watch this. No solution means the 2 lines are parallel. Now, the way that we're going to figure this out is we want these guys to have equivalent slopes. So first, I'm going to put these both into slope-intercept form. Actually, same slope, different y-intercept. So if I isolate y, I get y equals, I'm going to add 3x to both sides to get rid of that 3x, right? Let me erase that because I wrote over it a little bit. Okay, So y equals 3x plus 6 for the top one. Now this one, I'm going to subtract ax. I've got 2y equals negative ax, right? Oh, let's not do that. Negative ax plus 4. Divide both sides by 2. Y equals negative a over 2x plus 2. Okay. Now, so these already have different y-intercepts. We're good there. We need to figure out a way that these two can be parallel. So I need to know how I can make negative a over 2 equal 3, meaning what value for a can I get to make this true? Let's isolate by multiplying both sides. But see, now we just got a nice equation. We isolate, multiply both sides by 2, negative a equals 6. Multiply both sides by negative 1, a equals negative 6. 6, 3, yeah. Boom, done. All right. Multiple choice is done. Now watch the free response. I'm telling you 16 through 18 are usually a touch easier than those last few. So let's see. And we got 5 questions in 12 minutes. A manufacturer shipped units of a certain product to 2 locations. The equation above shows the total shipping cost T in dollars for shipping units and blah, blah, blah. If the total shipping cost was $47,000. Okay, hold on. Total shipping cost is T. So T is $47,000. And 3,000 units were shipped to the farther location. Farther location is F. And then we want to solve for C. So just plug and chug. We don't need to read this too carefully. 12 times 3,000. Okay, that's it. Just make sure you plug in correctly. 12 times 3,000 is 36,000. This is where the good mental math will come in really handy. If it's only good, if you don't have to write all that down, which is really you shouldn't, because it's 12 times 3. Subtract 36,000 from both sides. 5c equals 11,000. Divide both sides by 5. Now look, remember my trick to divide by 5. Divide by 10 and double it. So dividing by 10 is 1,100. Doubling that is 2,200. Okay. And you can check it if you want. I'm just going to roll with it. If it's wrong, it's wrong. But I would check it with this much extra time and do it again. Like plug in those values and make sure they all work. A and B are solutions to the equation above. What is the value of A minus B? Okay, first of all, let's solve this. How do we solve an absolute value problem? We first have to bifurcate, meaning split it into 2 equations. The first one is 2x plus 1 equals 5, just regular but without the absolute value. Second one, 2x plus 1 equals negative 5. Flip what is outside the inequality. Now we subtract. 2x equals 4. Divide by 2, divide by 2. X equals 2. Subtract 1, subtract 1. Negative 5 and negative 1 equals negative 6. X equals negative 3. So what is the value of A minus B? It doesn't matter which is which, right? So we'll just say like this is A, this is B. So it's 2 minus negative 3, which is just plus. So it's 5. Since I've circled a bunch of stuff, let me highlight this so I know what is the answer. Okay, cool. Let's make sure that's right. Hold on. Let me just process it for a second. Negative 3, 6. Yeah. And you see if I switch it, if I did negative 3 minus 2 would be negative 5 absolute value. We'd still get 5. So it doesn't matter at all. Next, Juan purchased an antique that had a value of 200 at purchase. Each year, the value of the antique increased by 10%. Okay, this is already an exponential. I already know. Where if it's the amount that it's going up by is in here and t goes out here, right? 200 is the initial. The increase would be in here. If it said a decrease of 10%, 0.9 would be here because it's 90% every year. The estimated value of the antique in dollars 2 years after purchase can be represented by the expression 200A, where A is a constant. What is the value of A? Okay, this is pretty tricky because, all right, actually, this formula is going to be hard to do without a calculator. So let's just do it by hand. So it's 200 and then initially, then after 1 year, it's 10% of that, which is $20. So 220. And then after 2 years, it's 10% of this, which is $22. So 22 plus 220 is 242. Okay. So now we know that in the expression said it could be 200A equals, and we already know now the value for after 2 years, which is 242. And then they want us to solve for A. So we're going to divide both sides by 200. A equals, let's divide everything by 2, actually, it'll be easier. So then it's 121 over 100. And now I want to represent this as a, like, you know, there's not even enough room to represent it like this. So any number divided by 100 is just moving the decimal 2 to the left. So this becomes 1.21. And that you can enter in the grid, no problem. Next, 19. Based on the system above, what is the value of 5x plus 5y? Oh, this is so beautiful. So this is actually really easy if you're careful. You don't need to solve for x and solve for y. Look, they want 5x and 5y. So if we just add these equations together, 2x plus 3x is 5x. 3y plus 2y is 5y. And then we have to add these guys, 1200 plus 1300, 2500. And that is your answer. See, if you just read carefully, I mean, look, that's 19. Usually 19s are pretty hard. And I think because most people just like, tunnel vision, I got to solve for x, solve for y, see a system. Just read a little carefully because they do that. Next, we got 7 whole minutes for this final problem, which is a lot. U plus t equals 5, u minus t equals 2. What is the value of this? Now, instinctively, what did I say? I want you to think about factoring and foiling, okay? Yeah, sure, I can plug in 2 here. But what about this guy? Well, if you recognize that this is a difference of squares, it's super helpful because it can be factored. Remember, every difference of squares can be factored like this. It's the square root of this goes here and here. Square root of this goes here and here. And then it's plus minus. Now look how easy this problem is once you do that, okay? U minus t is just 2. U plus t is 5. And u minus t again is 2. 2 times 5 is 10 times 2 equals 20. All right. And that's it. I'm going to stop the timer. So we finished pretty early. I do think this is on the easier side of tests, to be honest. But it is what it is. And by the way, I took this real test and I did not get a perfect score. I got one question wrong on the calculator, which I'll show you guys tomorrow which one it was. It's a really, really stupid mistake. But I remember I blazed through this test and so quickly. When I take it for real, I can obviously go faster because I'm not explaining it. I'm just going as fast as I can. So I finished this I think I finished this section in like 12 minutes. I finished the other one in under 30 minutes. It was really crazy. So that is an indication. But when it's on the easier side, the curve is really rough. So I got one question wrong and it was a 790. But that happens. Just really gotta be careful. Even myself, of making silly mistakes. So let's go through and let's see if I made any silly mistakes. We're about to find out. Let me load up the answers. Oh, the answers aren't on here. Uh-oh. Wait. What? Let me see if they're up higher. The heck? Okay, the answers are not on here. I can do a quick workaround solution. Hold on. I think I have them. Oops. Okay, let's see if I can find my scores. Where is it? These are the scores that I got. So this is the one where I got a 790. So the one I took in 2016, I got an 800. I'm taking it again this Saturday. So obviously shooting for that perfect as always. Okay, view QAS report. Okay. Hold on. How do I look at this? Oh, this is reading. We want math without calculator. And let's see. Okay, so this is not too bad. So we've got B, C. Okay, BCA. BCA. And then we've got DCCD. Wait a minute. Did I get that one wrong? What? Is number 6D? Oh, no, it's A. Sorry, ADCCA. DCC. And then 10 is, okay, we've got DABC. DABC. And then 14 is BA. Okay, all multiple choice are correct. Then 2200, correct. This one is 5, that's correct. This one is 1.21. Oh, you could enter, I guess, 121 over 100. I just didn't think there was enough room. And then 2520, I think that's what I got. 2520. Yeah. Okay, so everything is right. Everything is good. Let's go to questions now. All right, guys. And by the way, if you guys are watching and if this has been helpful and useful to you in any way, if you could please help me and click the like button. It helps my channel tremendously and helps spread the word about these live streams. So please click that like button right now. And, of course, subscribe if you want to see more. Let's see here. Keep up the good work. Hey, Fada, you're very welcome. Okay, can you repeat which one again? How do you think we should manage our time during the SAT math? You got to set your own pace. It's kind of like running, to be honest. You need to see what a reasonable pace is throughout the practice test. Like for me, I'm always shooting to have a spare. If I know if I've got a spare 5 minutes to work on that last problem, I'm in good shape. Just in case in the last couple, if they're really hard. So I'm always trying to get ahead, but that's not realistic for everybody. So you need to figure out what's a realistic pace, and then check in at the 5 question mark, 10 question mark, and make sure you're doing okay, or if you need to speed up. Just make 1.1 all squared. I think you're talking about this question. Yeah, I mean, I could have. That actually would have been totally fine. To be honest, 1.1 squared would have been very easy, Sarah. International. Yeah, so I'm doing the international exam on Wednesday. Yeah, Omar, you're right. Yeah, all you guys noticed. No, not times 2. It's not times 2. It's 1.1 to the second power is 1.1 times 1.1, which gives you 1.21, like that. Okay, number 2 again. Oh, number 3, sure, and 18. All right, number 3. Guys, how was it zoomed in when I zoomed in a lot? Was it easier to read? Can you guys let me know? Number 3 first. Okay. Okay, the table above shows shipping charges. Okay, look, this one is all about the fact that they say it's a linear equation. So as soon as I know that it's linear, I know that we're stepping by the same amounts every time. So to be honest, I probably should have used these guys. So all I had to do was to calculate the slope of this linear equation. I have to take the difference in the y's for a set coordinate. Let's choose this one this time. Difference in the y's over the difference in the x's. So if I do, what's the difference between these guys? And let's subtract bigger to smaller. So 31.79 minus 21.89. It's almost $10. It's $9.90. That's a little easier to process in my head. Over, okay, 20 minus 10, which is 10. So there's my slope. It's 9.9 over 10. Anything divided by 10, we just move the decimal over once. Boom. We have a slope of 99x, 0.99x. Okay, and then we need to calculate what my y-intercept is going to be. Is it going to be 0? It's not, because, okay, every time we're going down 1, I'm going down 99 cents. So we can clearly see that if I go down 5, I'm not going down, I'm not going to go down 16.94. That's too much. I'm going whatever 5 times 99 cents is, which is $4.95. But we don't even have to calculate that. We know that because there's only one option. It's either 0 at this point because I crossed these off, or $11.99. So $11.99 is the one that makes sense, and boom, that's the answer. Okay, now number 18. Hold on. Here we go. Juan purchased an antique that had a value of 200 at the time of purchase. Oh yeah, sure. Each year the value of the antique is... Okay, look. We know that this is an exponential equation because we're increasing by 10% over the value of the previous year, not 10% of the initial value over and over. So I could set up an equation like this. My initial value of 200 times, and it's going up by 10%, meaning it's 1.1. If it was going up by 5%, it'd be 1.05. If it was going up by 17%, it'd be 1.17. Whatever the percentage is, turn it into a decimal and then add it to 1, and that will give you what you need to go in here. And then this is to the t power, the number of years. So it says in 2 years, it can be represented by this expression. So what they're saying is when we have this for 2 years, we can represent it. The value is going to be 200a. And what is this at 2 years? It's 200 times 1.1 to the second power. All right. And now we can just solve for a. First, I should have set it up like this when I was doing it. This is much easier. First, let's divide both sides by 200, and that's gone. Now a equals 1.1 squared. And then 1.1 squared is, as I demonstrated before, it's 1.21. Actually, that's a much easier way to do it. Okay. I don't know what you mean to say the answers from the first, but slowly. I can answer maybe one more question, but I can't go through everything again. Any tips for chemistry? I think you emailed me about chemistry, Lewis. I don't really tutor or prepare people for the chemistry SAT subject test, so I don't have too many pieces of advice for you there. I'm really sorry about that. Thank you, Omar. I appreciate that. Yeah. Thank you. And again, if you want to watch this again, you can just wait till it's done streaming. It'll upload, and then you can watch the whole stream again in preparation. So, guys, tomorrow we're picking up with the calculator section. So I'm going to do the entire calculator section. And my schedule can be found on my YouTube channel. In the background, you can see the times listed. So, like, I'll show you, for example. If you want to know the schedule, that's where I posted it. Here, let's see here. Okay, so see in the background, it's small here, but you can see the schedule. So tomorrow, Tuesday, it's at 11 a.m. Pacific Standard Time, which is my time in California. And I think in Egypt, if you guys are watching in Egypt, it's 9 hours ahead, which is 8 p.m. at night. So we'll be doing the same thing. And I'll again be doing a paid session for anybody who wants to jump on. Same deal, for $10. You can jump into a private room with me through Click Meeting, and you can just fire away with questions and other math problems. Now, here's the deal. I'm going into the Click Meeting right now. If you want details on how to join that meeting, okay, look in the description below. There's a link that about Click Meeting. You click that, and you can pay through PayPal, and then you can enter the room and throw out additional questions. I'm doing the March Makeup International on Wednesday and Thursday. I probably do the March Makeup on Friday. I was going to do something else on Friday, but I'll probably just do it on Friday. And I'll do the full thing. I'll do the calculator and no calculator. Okay, so again, guys, thank you so much for joining. I hope this was helpful. I really appreciate the support and the fact that you guys are coming in and trying to improve and get strong on your SAT math. Okay, you're asking for number 3. I can probably do number 3, and then I got to roll. I already did number 3, Iman. So I just did that one. Khalid, I'll do number 8 for you, okay? And then that's it. Okay, so number 8, check this out. In number 8, we have, it's saying point B lies on AD, whatever. All we got to deduce here is the fact that they're telling us that this is a right angle and this is a straight line. If this is a right angle and this is a straight line, this other side is also a right angle, meaning it's 90 degrees. Now, If that whole thing is 90 degrees, I know that these three angles comprise that angle. Therefore, these three angles must add up to 90. So I can then make up an equation that says x plus 2x plus 2x equals 90. We know that to be true. X plus 2x is 5x. And then we divide both sides by 5. And x equals 18. Okay, remember my trick to divide by 5. Divide by 10. 90 divided by 10 is 9. And then double it to 18. And then if x equals 18, what is 3x? Plug it in there. 3 times 18 is 54. All right. Okay, guys, that's it for today. I wish you all the best of luck, and I'll see you guys tomorrow. Make sure to jump on. You're very welcome, Muhammad. And again, if you want to join the private session afterwards, look in the description below and go to Click Meeting, and I'll see you guys there shortly. We're probably going to get rolling pretty soon, maybe. Actually, I'll probably get rolling in the next few minutes. Thank you guys so much, and I'll see you all next time. Take it easy.